What I'm actually going to do now is I'm going to go through one final example, which is in your book. This is a final example here, where we have to use exact values. Now this one's a little bit trickier. So let's have a look. We want to find the value of x giving your answer as a third. You find the value of x giving your answer as a third. Now in this question here, we've got, if you have a look at my diagram, I'm only given the length of two sides. If you have a look, I've got my side x over here, and my hypotenuse, which is the length directly opposite my right angle, is 3. So I have that length over here. But I don't have the length of this other side over here. Is there anything in the diagram which can help me figure out what that length is? Well, I won't know the exact value of this length here, but if you have a look at the diagram, these two sides, this side over here, and this side over here, they both have two lines through it. When you see two dashes or the same number of lines going through it, so if you see over here and here, those lines tell me that those two sides are exactly the same. So if this side over here has a length of x, that tells me that this side over here has a length of x as well. Great. Okay, cool. So what I'm going to do is I'm going to use Pythagoras' theorem to help me find these missing sides. Now, at this point you might be like, so don't we need at least two numbers? Well, here, we don't actually need it. I'm going to show you. So let's do the step that we have been doing so far. First step, I'm going to write Pythagoras' theorem. What I'm going to do now, instead of doing that, substituting and rearranging all in one go, I'm actually going to substitute my values in first. So let's have a go at that. Firstly, what is the value of c? C is just the length of my hypotenuse. So if you have a look at my diagram, it's the length that is directly opposite the right angle. So here, for c squared, I'm going to write 3 squared. That was the length of my hypotenuse, so I'm going to write 3 for that length here. Okay, now that I've got that, I'm going to substitute the values of a and b. Now, a and b are just my two shorter sides. Now, if you have a look, the two shorter sides, they both value x. They both have an x in it. So for both of them, I'm going to write x squared. I'm going to write both of them as x squared. Now, in the last topic, we had a look at something that looked exactly like this. These two are called like terms. They have the same pronumerals and the same powers of each one of those pronumerals. If you have a look, they both have x's, and both of these x's are squared. So what we can do is we can add them together. If I have one x squared and another x squared and I add them together, how many do I get? I get 2x squared. So here I'm going to write in the following step, I've got 3 squared is equal to 2x squared. Okay, I'm going to rearrange my equation now. So we've got 2x squared is equal to 3 squared. Okay, now that I've done that, I'm going to find the value of 3 squared. So if you have a look on the right hand side, I've got 3 squared. I've got 3 squared. What does that give me? 3 squared is just 9. So here I've got 2x squared is equal to 9. Okay, now this is the tricky part. Now here, when I've got an x squared and I've got numbers as well, the first thing I deal with the numbers first. So here I've got 2x squared. If you remember, 2x squared, it's just the same as doing 2 times x squared. So if I want to get rid of 2 times x squared, what do I need to do? What's the opposite of timesing by 2? Dividing by 2. So what I'm going to do is I'm going to divide both of the sides by 2. So I'm going to go divide this side by 2, and I'm going to divide this side by 2. And so if I divide the left hand side by 2, I'm just left with x squared. But on the right hand side, I'm actually got 9 over 2. 9 over 2. Now that I've done that, I don't want x squared, I want x. So I'm going to put in the square root of 9 over 2. Then they ask us to leave the answer as a third. Now you can actually move, in the later years, you'll actually deal with thirds in a little bit more detail. What you can do when you have thirds is you can take the square root of both the top and the bottom separately, and then deal with those separately. So here I'm going to just have, if you have a look, I've got the top is square root 9, which is just 3, and at the bottom I can't do anything to square root 2, And so this is that final answer here, 3 over square root 2. Now this example is a little bit tricky, and there's a few examples of this, but have a go through these steps again. Hopefully they're helpful, and if you have any questions, feel free to ask me on the Google Classroom or send me an email. I'm more than happy to help. All the best, and I'll send you, have a go at the questions that I've assigned for you in this chapter, and if you have any questions, feel free to ask.